Section 7.3, Logarithmic Functions. The essential question: how can I write equivalent forms for exponential and logarithmic functions? How many times would you have to double $1 before you had $8? You could use an exponential equation to model this situation. Start with $1, doubling, that's our base, 2 to the x equals 8. You may be able to solve this equation by using mental math if you know that 2 to the third power equals 8. So you would have to double the dollar 3 times to have $8. How many times would you have to double $1 before you had $512? You could solve this problem if you could solve 2 to the x equals 8 by using an inverse operation that undoes raising a base to an exponent equation to model the situation. This operation is called finding the logarithm. A logarithm is the exponent to which a specified base is raised to obtain a given value. That is important, and I'm going to highlight that right now. A logarithm is the exponent to which a specified base is raised to obtain a given value. So I always like to write it like this: log equals exponent. You can write an exponential equation as a logarithmic equation and vice versa. And that's what we're going to learn how to do right now. So b to the x equals a, that's an exponential equation. Log base b of a equals x, that's a log. Recall, b must always be greater than 0 and b can never equal 1. And so this is going to show us how do we go from exponential to log and log to exponential. Well, notice the base of the exponential, b, that becomes the base of the log. The exponent, which is the x, remember I said log equals the exponent. The exponent is always on the other side of the equal sign. And then the a value goes right next to the log. The best way to go through this is with an example. All right. Example number 1. We're going to convert from exponential to logarithmic form. Well, first of all, we need LOG. The base of the log is the same as the base of the exponential, which is 2. So that's a little 2 that goes right there. Not a big 2 next to the LOG. It's a little subscript. Now I leave a space, log equals exponent. The exponent is a 6. Well, what didn't I use? I didn't use the 64. And the 64 is a bigger number, size-wise, sitting right next to log. The 2, the base, that's the little subscript. If you look back here, it demonstrates it right there. Log base b, a, if you can, and this is important. I'm mentioning this because it's important that you write it like this. The a is set up right next to LOG. The b is like a little number that goes a little below LOG. All right. Next, log base. Well, the base is 4. Little 4. I leave an opening, equals the exponent, which is 1. I didn't use the 4. Let's do another one. Log. The base is 5. Leave a little opening, equals the exponent. What didn't I use is the 1. Log. The base is 5. Leave an opening, equals the exponent. The only thing I didn't use is the 0.04. And again, log, base is 3, leave an opening there, equals the exponent, 81. All right, just double checking that everything looks good, and everything looks good. So we just went from exponential to log. Now we're going to go from log back to exponential. And we start with the base of the log, which is 10, and we're going to raise 10 to the exponent of 2, and that is equal to 100. So we start with the base, which is 10, raised to a power of 2 equals 100. 7, we start with the base, 7, called the wraparound. Go to the 2 and the 49. 7 raised to a power of 2 equals 49. 8 raised to a power of negative 1 equals 0.125. 8 raised to a power of negative 1 equals 0.125. Here, the base is 5. 5 raised to a power of 1 equals 5. 5 to the first equals 5. 12 raised to a power of 0 equals 1. Let's fix that. Equals 1. All right. All right, that looks good. I'm going to write a little note over here. My little rule of thumb is when I go from log to exponential, I start with the base, like I said, b, and we go b to the power of x is a. B to the power of x is a. That's what I was trying to say when I went and did this example. So we've gone from exponential to log and log to exponential. We converted between the two forms. All right. A logarithm is an exponent. So the rules for exponents also apply to logs. You may have noticed the following properties in the last example. So let's go over the special properties of logarithms. For any base b such that we always know b is greater than 0 and b does not equal to 1, the log of base b, then we have the exponential form, and here's an example. So if we have a log of base b, if we want to convert that to exponential, we start with the base. B to the first power is b. B to the 0 power is 1. A logarithm with base 10 is called a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. You can use mental math to evaluate some logarithms. Example 3. Evaluate by using mental math. So if I am given a log equation, to evaluate that, we have to change to exponential. If there is no base listed, it is assumed to be a 10. So if we convert from log to exponential, remember we always start with the base. 10 to the power of x is 0.01. 10 to the power of x is 0.01. Oh, well, 0.01, we can write that as a fraction. That is the same thing as 1 over 100. They're equivalent to each other. Well, the question we ask now is 10 to what power is 100? Well, we know that 10 squared is 100, but it's not 100, it's 1 over 100. So then it's going to be 10 to the negative 2 is equal to 1 over 100. We're solving for x. X is equal to negative 2. So whenever we have a base raised to a power and it's equal to 1 over something, then the exponent is going to be a negative. Example 4. Evaluate by using mental math. Oh, they gave us the base. So we have to change to exponential. 5 to the power of x is 125. 5 to the power of x is 125. Oh, we ask ourselves, 5 to what power is 125? Well, 5 to the third power is 125, so x is 3. 5 times 5 times 5 is 125. Evaluate by using mental math. Again, we have to change to exponential. Oh, well, notice on example 4, we had an equation, log base 5 of 125 equals x. On example 3, we had an equation. Example 5, we don't have an equation. That's okay. Log equals exponent. We make it into equation. And now we change to exponential. 5 to the power of x equals 1 over 5. Well, remember what I said. When you have a base raised to a power and that's equal to 1 over something, I know that my exponent is going to be negative. Well, we know that 5 to the first power is 5, but we don't want that. We want 1 over 5. So it's to the negative first, negative 1. So x is equal to negative 1. Video questions. Write each exponential equation in logarithmic form, and then write the logarithmic equation in exponential form.